Hello, Mr. Luong. This is FRQ9. So for part A, to draw the velocity function, I'm going to find the slope of these parts because when the position function is a line growing at a constant rate, that means the velocity is a constant, which means the velocity is going to be a straight line, and whatever you get for the average velocity is going to equal the velocity from 1 to 8. So to find the velocity from 0 to 8, I'm going to do average velocity equals displacement over time. Then final position, I'm going to choose from 0 to 6. So xf is 6, xi 0. The time it took was 4 seconds. So average velocity is going to be 1.5. And for this one, I just do the same process because whatever you get for average velocity is the velocity. Because since the velocity is constant, the velocity will stay the same as the average velocity. And for this one, I'm going to choose xf is 0 minus xi at 12. And time it took was from 20 to 25, so 5 seconds. Then average velocity is going to be negative 2.4. And then I'm just going to graph this at 1.5. So from 0 to 8, the velocity is 1.5, which stays constant. So since 1.5 is the velocity all throughout 0 through 8, that's why it's the average velocity. And then it goes from that to no velocity because it's not moving, so there's no velocity. And then it's not moving from 10 to like 18. And after 18, I'm going to draw a line that connects it to negative 2.4. So 2.5 is around here, so 2.4 is somewhere around there. So then negative 2.4 right there. And then, oh yes, it's going to stop at 25 seconds. Okay. Next question, to find the average acceleration, I know I can do A equals change in velocity over change in time, and average acceleration from 8 to 10. So 8 to 10, the final velocity at 10 seconds is 0, minus velocity at 8 is 1.5, over how long that took was 10 minus 8, so 2. So average acceleration is going to be negative 0.75 meters per second square. And to represent the direction, and then for C, to draw a vector to represent direction of acceleration, it's the acceleration, I'm going to draw it right here. So that's the box right there. Acceleration is just going to be downward because the velocity is decreasing, so that means acceleration is negative, so that's why acceleration is pointing down. And then for D and E, I'm going to prove it with Fn minus Fg equals to ma, right? And since there's velocity is constant, which means it's not changing, so that means that there's no acceleration. And since there's no acceleration, there's going to be 0. And then you just move Fg's other side, and that's why for D and E, the vectors for Fn and Fg both look equal in magnitude. So that's Fg and Fn. And then same for this one. Yeah. Let's move this up a bit. Yes, so that's for D. And this, oh, I accidentally drew Fg up there. What? Okay. Fn, and that's Fg. Okay. And I know these are correct because at 6, it's moving at a constant velocity, so there's no acceleration. So that's why Fn is going to equal Fg, and same with at 24. there's no acceleration because velocity is constant, so that's why Fn is going to equal to Fg. And then F is going to use the same principle from D and E. Since it's at 4 seconds, there is no acceleration, so Fn is still going to equal to Fg. So then Fn is going to equal to mg. Fn equals to 70g, which is going to equal to 686.